Hello everyone, it's Miss Thomas, and today we're going to be looking at special right triangles. So special right triangles are triangles that a special relationship holds between their sides. There's an alternative way to find the sides of these triangles besides using the trig ratios or Pythagorean theorem. And usually memorizing these relationships will help you down the road when these special right triangles are used in other application problems. So the first special right triangle is the 45-45-90 triangle. So the 45-45-90 triangle is a special right triangle. The special right triangles are referred to based on their angle measurement. So those are 45 degree, 45 degree, 90 degree. So we know that if these angles are congruent, that the legs also have to be congruent by the isosceles base angle theorem. This has to be an isosceles triangle because I know the base angles are congruent, so the sides opposite of those angles are congruent. So even if I don't know how big that side is, I know that if this side is x units long, from here to here, then this side, this leg also has to be x units long. And this actually will help us determine the relationship with the hypotenuse. So using Pythagorean theorem, if we want to know what our hypotenuse is, it's a little question mark, right? It is leg squared plus leg squared equals hypotenuse squared. So I don't know how long my legs are, but I know that if I square each of them, then that the sum of those squares will equal my hypotenuse squared. So because they are like terms, they're both x squared, so you can add them up, and that would give you 2x squared. So 2x squared should equal c squared. Well, keep in mind that if I want to solve for what my hypotenuse is, I would take the square root of both sides to get my hypotenuse alone. So my hypotenuse, which is c, is going to equal whatever the square root of x squared is. Well, the square root of 2x squared. Square root of 2 is not going to be able to be simplified, but if I look at the x squared, square root of something squared is just that item. So the x will get out even though the 2 will stay in. So in a right triangle, special right triangle, the 45-45-90, if your side lengths are x, your hypotenuse is always going to be x square root of 2. So how will this help? So a little bit more cleaned up. This is generally the way you'll see the information presented in a 45-45-90 triangle. The legs will be x, and then the hypotenuse is x squared of 2. So I can show you an example of this. Here's a 45-45-90. I know it's 45 because if this angle is 90, this is 45, and the third angle has to be 45. So if the angles are 45, I know that the legs are congruent, so automatically I know this also has to be 3. And then I know that the hypotenuse is x square root of 2. Well, x is whatever the side length is. So the hypotenuse is 3 square root of 2, and I'm done. I didn't need Pythagorean theorem. I didn't need SOHCAHTOA, although SOHCAHTOA and Pythagorean theorem will lead to the exact same result. So 30, 60, 90 triangles are also considered special right triangles. They also have a relationship between the sides. Generally, everything in a 30, 60, 90 triangle is in reference to the shorter side. So the short side is across from the 30-degree angle, and then all the other sides are related to that short side. So the hypotenuse is twice the short side, which is easy enough. And then the long side is, the longer of the legs, is the short side times the square root of 3. So I would really recommend, if it is confusing with just the variable form, I really recommend writing it out with words. So let me show you what that would look like. So here is the relationship of the 30, 60, 90 triangle written out with two equations with words. One is just saying the hypotenuse is twice the shorter, and the other says the longer of the two legs is square root of 3 times the short leg. Okay, so let me show you some examples where this will be used. Okay, so in this problem, we want to find the lengths of the missing sides, and we've got a 30, 60, 90 triangle. I really do suggest that you label the sides of the 30, 60, 90 short. I know the shortest one is across from the 30-degree angle. Longer, the longer of the two legs is across from the 60, and hypotenuse. So we've got this 30, 60, 90, and we want to make sure that we understand the relationship. So I just go ahead and write out the verbal relationship. I know that the hypotenuse is equal to 2 times the short. So my hypotenuse is going to be equal to 2 times 4, which is 8. So this is one of the sides. I know my longer leg is equal to the short leg times the square root of 3. So in this case, the long is going to be 4 square root of 3. And those are the two side lengths that are missing. Now, this is a situation you could have used your trig ratios to solve for these sides as well. You can easily, since you know one of the sides, you know the angles, you can use trig ratios to solve. I do really recommend, if you think you're going to be taking advanced mathematics, that you memorize these. It'll save you a lot of time, and you'll recognize the pattern more readily. But if you're feeling overwhelmed, if you're feeling like, I'm not going to be going to advanced mathematics, and I really understand my trig ratios, just stick with the trig ratios then. This is good for people who are planning some more math in their future. You want to learn this stuff. Okay, here's another example with the 30, 60, 90 triangle. But in this situation, when we look to label our sides, we don't know the short, and we don't know the hypotenuse. But we do know the longer of the two sides. So you generally want, if you don't know the short yet, that should be your first thing that you solve for. So I'm going to go ahead and set up the equation where the long is equal to the short times the square root of 3. And I'm going to plug in what I know. I currently know that my long is equal to 4. So 4 is going to be equal to short square root of 3. I'm just putting SH for now. So the short and square root of 3 are connected by multiplication. If I want to figure out what my short is, I'm just going to divide both sides by the square root of 3. So in this situation, you can certainly end up with a decimal approximation. And then you want to make sure short is equal to 4 over square root of 3. As you may or may not remember, when you have square root signs, they cannot be in the denominator. Okay, so I just want to sort of make some things clear. This is the answer, but, and this is a big one, you have to rationalize the denominator. So, and you may remember that rationalizing the denominator, this is where, if I'm trying to take this current answer, 4 over the square root of 3 is equal to my short side, right? And I'm going to rationalize the denominator. I need to multiply numerator and denominator by the square root of 3. So then, because square root of 3 times square root of 3 will give me a square root of 9. And what I end up with for my final answer in proper notation is 4 square root of 3 over 3. So that is my short side, the length of my short side. So I can use that to help me find my long. I'm sorry, I already know my long, to help me find my hypotenuse. Okay, so to find my hypotenuse, I'm going to write down my equation, 2 times short. So my hypotenuse is equal to 2 times 4 square root of 3 all over 3. So really my hypotenuse is equal to 8 square root of 3 over 3.